After 1, 2, 3, 4 for students here. Where are other students? Yeah, you just ask them, where are they? Or they are online? No. So the class study at so
How about break time? By that time you won't be around. But sometimes you come from
they are online and then yeah. My view.
맞아요. 노이즈.
Okay, we start our class. The next class, we just learned how to draw the study tolerant the diagram. We learned the 6 or 5. The terms is about the tolerance. all about the procedure. Is like the for the whole is EI, the up deviation. ES is up deviation. EI is the low deviation. And for the ES, EI, and the tolerance is T. Is like PH. Is T. Is the T is capital T. Is the T is the tolerance. The first letter is tolerance T, and the H is the whole, right? It's the whole, and the T is the tolerance, and the H is stopped, right? So and the ES is up deviation, EI is the low deviation, and D max, the maximum limit of the size of the whole, and the D minimum. And 1, 2, 3, 4, 5, and the basic size is D, right? And D. So this is ES, EI, D max, and D minimum. And we also learned how to calculate the size, calculate the value. If give you two of the terms or two of the values, two values, and this is the homework. Someone just finished this one, finish this one, right? And also is this one. So do you think this one is difficult or not, or it's easier? So it's difficult, complicated. So if you listen and carefully, and you can know how to do that. I give you two. I try to explain how to do that before I explain it. I just to find your book, the page 20. You have the book, or just to find the PDF. I will try to explain the summary of the feet. How to do that? So, that is how to do the how to explain the summary of the field type according to the deviation's value. So there are 3 types of the fit. Is the clearance and transition, and yes, interference. So how to diagram, how to tell what the type of it. So last class we talked about if the maximum hole to fit the minimal shaft, it have a clearance. So if I mean that is a maximum hole minus the minimum shaft, so the value is plus. So it's a clearance, right? So like the minimum maximum hole, so is D max, right? To minus the minimum shaft, so it's the value is the class, so it's clearance, right? So this is the maximum clearance, right? So if the minimum hole balance the maximum shaft, the value is plus, so it totally is clearance, right? It means that it means the hole is here, right? The shaft is here, right?
Yes.
The maximum hole, this is maximum hole is the minimum shaft. This is the minimum hole, this is the maximum shaft. It's clearance. This totally is clearance, right? So if the maximum hole minus the minimum shaft is plus, it means that it means that the plus is here, right? So now maximum hole balance the minimum shaft. So it's plus, it means that this one that this one is clearer, right? And this the maximum here, maximum here, maximum here, and the minimum is the maximum here, and the minimum here, right? Is shaft is plus. If the minimum, I mean minimum is balance the maximum is 1. Is minus, it means that the maximum maximum is, let me see, here is the clearance, right? This is the maximum, this is the minimum here. So it's minus, so it's here, right? 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 This is the transition, right?
Yes.
So if the maximum hole minus the minimum shaft is minus, it means that this is the maximum. This is the maximum hole. This is the everyone is that is the minimum shaft. So this shaft is over here, is here, right? So and the maximum, this is the maximum, this is the minimum, right? Is up, this is down. This is minimum, and this is maximum, right? So this is the interface. Interference. So this is the minimum, the maximum is also we can describe with ES minus because this is D plus ES, this is D minus EI, right? D is the base size, they are the same,
Yes.
right? So it also this is the ES, EI balance ES. Sorry. Oh, sorry. EI balance not ES, right? Is the class, is the value, is the class balance or something. So back to this homework.
The theorem.
The theorem here,
Give the minus up and the minus down.
the minus is down, yeah, minus down. Thank you. The field, so like this, the homework. So the 550. This is the, so this is the minus, right? The minimum or the one maximum. This is the minimum clearance or the maximum interference, right? So is the is the minus 0.008. So if we try to draw the tolerance diagram. So TH, how to calculate the TH, the tolerance of the hole, right? TH, how to express if the up deviation of the low deviation is ES minus yeah, right? TH equals ES minus yeah, right? It equals 0.018, right? So the ES equals 0, right? So 0, right? So ES is here, 0, right? This is ES. This is fact. Yes. TH. And the minimal clearance or the maximal interference. This is the maximal interference, right? Because the symbol is minus, right? So is how to calculate the maximal interference is E maximal. Yes, EI minus ES, right? This is interference. Yeah, it matters is the maximum. Oh, sorry. Is EI minus ES, right?
Yeah.
So is the minus 0.008, right? Right? So the clearance, the average clearance equals this is the value. This equals this equation from the book is a clearance, is average clearance. So is 0.5 is one the half of the maximum and the minimum. Maximum and the maximum, or maximum and the minimum. This means that the maximum clearance or minimum clearance or maximum or minimum or maximum interference or minimal interference. So this is this right? The E or the E equals to EI plus EI plus ES, right? Right? Equals plus 0.065. So you just use this 1, 2, 3, 4 equations to calculate the ES, EI, EITH, or maximal clearance, or minimal interference. So this is ES. So the EI is minus, right? The EI is minus. Yeah, it's minus 0.005, right? Is but ES EI is minus here, right? 0.0. 0.08. So this is minus 0.008. So this one is
positive 0.011.
yeah. Is plus 0.010, right? No, 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 no.
0.011.
No. 10. This is ES plus 0.008, right? So this is 0.012. So this is 0.010, right? Right? So this is here. It's 10. Right? So this is TH. TH is X, right? So the still EI. So this is 0. This is minus 0.008. So this is plus 0.010. So and then we can to calculate this one, right?
Yeah.
So this one is minus. This is 0. 1. So this is the first one. The second one, the third one is the same. Understand? Is average, because we have the average mirror or average. Yeah. How about this one? Okay. No. From the yes, 0.018, right? EI. And then EI is function. For the theorem here, in the theorem, minus 0.008. So that the mean of the low derivation is minus derivation of the chart. The maximum theorem is minus 0.008. You can calculate the EI. When you calculate the EI from this, yes, right? From the yes, and the new equation you calculate the okay. Do you have any questions? Hello? So they have the students online just they have 5 or 6 or 7 homeworks. You to me, you just give 7 or 5, 7. I think it's 7 homework to me. The list of the students. Could you give your homework to me next before the next class before two days of the next class, the due date. Hello? No one here.
Can't understand, Laushi. Can you please
Continue
tell
our
again?
class. This okay. We'll need to talk about the new content. I mean this homework of this class. I think it's a little more difficult than the last next one. So just listening very clear, carefully, very carefully. Okay, it's very complex. There are so many terms here.
It's chapter 3.
Huh?
Chapter 3.
No, chapter 3, the chapter 2.
You are going to chapter 3, right?
No, the chapter 2. They have still continue. This is chapter 2. The laser. The standard of the limits of the fees because last class we just to learn how to calculate the tolerance, right? The up deviation, the low deviation. They have some problem.
The black. Never see the people they look at the blackboard very close. Hello. 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 It's not.
Last year.
Some noise or there are anything else? You can
I want to close this thing, but I don't
oh,
understand.
close this. See. Close this thing. This is where?
But I wonder.
Oh, from here. I don't know how to call them.
Two participants.
So this is just change the English or Chinese. Yeah.
This is the class. Okay.
Yes.
Mm.
This one.
Come.
Oi.
Please. They can hear. They can hear. I just.
Here.
They can hear.
Oh, they can hear.
Open this. Let me see. Open it. This one.
This one. Now it's hot. This is the.
Hello.
Okay, now this one.
Okay, you
try. You try. Okay. Okay. Continue our class. The last class we just learned how to calculate the up deviation. The up deviation, the log deviation, and actually we cannot to calculate. We can, but I mean this word. So this word, you can't log to if you are a designer. So how do you to design this values, right? Yeah, you can to you cannot to design the word. So that is the standard. This is standard. I mean the procedure is a standard. If I give you a shaft, it's diagram is 50. For the shaft or the hole, the tolerance is standard. So and this class, I just tell you how to find the table and to calculate the tolerance. Okay, and it's initially it's very easy just to find the table and to find what the tolerance it is. Okay, the standard tolerance grades. The standard tolerance grades are designed by the latest IT. This IT it means the tolerance, like the zero. This is the tolerance is IT. The tolerance how long how length or how long length of it is, how big or how large it is by the number. So there are 20 standard tolerance grades designated TI01, TI0, TI1, continue to TI80. So there are 20 standard tolerance. That you mean that is standard tolerance grades at 20 from the TI0 to TI80. When the range, I mean the diagram, or from 0 to 3,150. It means that different diagram of the shaft or the hole, they are have the different IT, right? For example, like this table, the basic size is the D, is a capital D or small d, right? The capital D for hole, small d for the shaft. So they are the same, like the basic size of the diagram, like the 3. If the diagram of the shaft or the diagram of the hole is smaller than 3, so you can choose the IT1, IT2, IT3. Just notice that this is the unit is right? So this is tolerance. Tolerance is You can find it from the table. The size tolerance expresses the difficulty degrees of manufacturing. It also represents the procedure of the workpiece. It means that the individual size, your basic size, like for shaft, so you is 20, right? 20 is 20. It's from here. It's larger than 80, smaller than 30. So if I give you the tolerance is IT1, the procedure is IT1, so his tolerance is 1.5, right? It means that is this one is 1.5, so it means that it's very difficult to manufacture, right? So if the IT is 20, is IT7, so it's 21 unit so it means easier, is competitively easier to manufacture, right? So this phrase, it means it's difficult to manufacture or not. So the tolerance value is less, the manufacturing is more difficult, right? And the procedure is higher, like the table. So the grade number is smaller, the tolerance value is smaller. It means that the grade number is smaller. This one, like this one, the grade number is 101, and to compare the 0.7, so this is 0.8, this is 10. So this IT1 is the procedure is higher than the IT7, right? So and that if you for this one is for the compressor condition. This one is for not the higher precision. Another word that in other word like this, you can use laser or you can use tone to manufacture this procedure grade, and you can use grinding to manufacture like this 0.8 this procedure. So different manufacturing method you can get different procedure. Okay. So like this one, the 50, the diagram, no, the basic size is 50. His tolerance is 0.012. So like this one, so this is difficult to manufacture, right? So the tolerance is relative to the basic size. So at the same tolerance grade, the manufacturing difficulty should be the same, right? The different, the same grade is the same because like back to the table, the same, this tolerance the same, so the difficulty is the same. So the basic size is stepped. Can say because this is the same and the basic size is stepped, and for the procedure, for the grade, the tolerance grade the same, the procedure is the same, although the word is larger than this one, but the basic size is stepped. Can you understand me? Okay, get me? So that comes the table. And to open that, so that table, you can to find your book. Oh, sorry. This is the table. You can find your book, table 2.3. This table is means that how to calculate the IT, the tolerance grade. You just to know how to calculate that. Okay, equals 5. This is it's a picture.
It's a picture.
Yes.
The problem is this.
Here, method is future. Okay,
This.
yeah. Just to learn this table is not very important. It's okay.
It's okay.
It's okay. Okay. Thank you. So this table is mean that tell you how to calculate it. Calculate it. Where? Where? How to calculate that? If the, for example, if for the IT01, the table 2.3 table, the page 26. Okay. So if the diagram is this D is the basic size, right? So for example, the basic size is, let me try, it is 6. Okay. So the basic size is 6. And then use these equations to calculate the tolerance. 0 plus 0.008 D, right? For example, so this D is for example 6. So 0.3 0.000 multiply 6. So how much is that? So this is 0.348. Yeah. 348 is IT. 6 is IT1 table. IT1 01 0. Oh no, this is not 01. Not another one. IT1. There is no IT001. This is IT1 is now this one. Okay. 8 plus 0, 0, 2, 2. So this is 6. 0 to 8 plus 0, 0, 2, 2, 1 plus 6. 0, 8 plus 0. Right? So it's minus, it is 0, 1, 2, right? So you can find the table is 27. in table 2.4. So you can find the 6. So the IT1 is 1 UM, right?
Yes.
So it's UM. And it's almost almost the same, right? So this I will give you this example, like this one. It just give you how to calculate the IT, the tolerance, the number values of standard tolerance, the tolerance. Yeah, the tolerance. Well, these equations just you give you many experience. You can get the experiment equation and to calculate the IT1. Yeah, actually, you cannot to calculate that, calculate it. You just to find, you just know how to find that. Actually, this is the 0.93, right? So, for example, if give you this is the diagram is 6 or diagram is 5 or diagram is 4, and you can get different. This one, the tolerance, right? So for the easily to use this standard, the engineers just give you this when the basic size is range is in from a range and the tolerance is the same. And you can to find the tolerance. You don't need to calculate that. And I just let you know how to calculate that. Okay? Got? Ah,
How do you express this? How do you express this?
how to use this one?
How to
So this is the basic size is from 0 to 3. This 3 millimeter.
express this? 0 is greater than 0 but equal to 3.
Yeah, equal.
Greater than 0 equal to 3.
Equal to 3 is smaller and equal 3.
Okay.
So this is larger 3, smaller 6 or equal 6.
Okay.
Okay. So the value how to calculate study by yourself. And I can give you example how to calculate that, right? So if I interested to visit, so you just can look up the value is okay. So if you are interested how to calculate it, you try to calculate it. But the number or the word, the values, you just look up the table 2.4. This is standard. Okay. For example, look up the tolerance value. Given basic size is 16, IT7. So how much is it?
Then I want I 7. I want
87. Huh? Yeah, 30.
yes.
Good. And another one. Seven, eight. 8 is 87. 87. Huh? Where?
46.
Yeah. 46. So everyone knows how to find the table. It's very important for the engineers how to know how to find the table. Okay. You know how to find the table?
How about the table? How about the table?
You want? Oh, the table. Table. Here. Yeah. here.
Now you can explain.
Display, okay. So like the IT 7. Wait. IT 7. Huh? IT 50. No, I mean that the 80 is smaller, 80 and equal. That means this one, okay, so it's larger, 50, plus 50, and equal and smaller, 80. So this one is the large 80 is like 81. If 80 is this range, to equal 120 and smaller 100, like 100 line. 100 lines in this range. And then
See, this one is 0. Like there's nothing starting with 0. So forget this one. Let's do this. This is greater than 3. You understand? So it's greater than 3 within the range, equal to or less than 6. So 4, 5, 6. So if she gave 50, right? 50 means this one is greater than 50. So starting from 51. So if you are looking for actually 50, you have to come here. But it's 50. Yeah. 3. The basic size is 3. Means it's equal to 3. So you take here. So IT, maybe IT 5, so forth. But you see where the confusion came in the other one. She said 8, IT 3. It ends here. You don't use this 8. But it's greater than 8. So you start from 81. IT 8, this one ends at 8. So IT 8. IT 8 is what's it?
can you understand me? Understand him? He meant that how to find the change and the IT, find the IT like the IT 5, and the basic size is 80. So it's 8 is here, equal, smaller or equal 80. So IT 5 is here. So his tolerance is 30. The unit is UM. Yeah, the 30 UM. Okay.
Why is the IT 12 to IT 18 or 22?
IT 12?
IT 8, they are limited.
Where? IT 7? IT?
From IT 4 to IT 18.
Limited.
Oh, this is because it is very large. So the tolerance is large, and the value is large. The tolerance is large. So this is MM. And another one, and another terms is the standard deviation. So if you learned the tolerance, it give you the tolerance or the basic size, and I give you just the tolerance, and let you to manufacture IT7 procedure, the size, and you know the TS, right? The tolerance, I can give you IT7, and you know the tolerance, but you don't know the up deviation and the low deviation, right? So if you know the up deviation, one of the up deviation or the low deviation, you can know his position, right? His position is like this is 0, and you know this one, you know this value, you know the position, right? So the fundamental deviation, so is the position deviation. Is presented the position tolerance with respect to the 0 line. So this is the fundamental position. It's close to the 0 line. So this is 0 line. So for the shaft, there is the up deviation, right? So for the hole is the low deviation, right? Because this is the basic is to close to the 0 line, right? So it's related to designate the fundamental deviation position. like this one. The capital letters for the whole is the same. The low letters for the shaft is A and continue to ZC. So there are 28 fundamental deviations. To avoid confusion, some letters are not used. I mean that A to ZC, and some words like I, L, the I is equal to the EI or ES, EI or EI. The L length of the O or the Q, W. We cannot use that. We just use A to ZC, and part of them are double letters EF or ZC. Let me, for example. So this is for the whole. The whole deviation. It means that the first one, so is the fundamental deviation is close to the zero line, right? This is 0.9. So for the whole, like his tolerance is larger than 0. I mean that tolerance is up, is here. So is this deviation. So this is the fundamental deviation. Until to JS, the H, its deviation is 0, right? So for another one, the deviation is low, the tolerance is low to 0. So this is the deviation, the fundamental deviation. So it's EI. So you must know this is ES, this is EI, right?
So actually, MN is also EI.
N, right? So this is the spatial we learned later. This is EI. Yeah, it's EI. This is EI. So this is the C method. JS.
This one.
JS is the symmetry.
Symmetry.
Yeah, symmetry. So this is the spatial JS, JMN. So the PRSTUWZC. So this is the EI. So from A to H, so is the up and the larger than 0. So this is EI, right?
Yeah.
So this PRST is the ES, the deviation. So we can find the fundamental deviation from the table. Okay, so from A to H, the fundamental deviation is EI. It means that position, this is his position, and the tolerance we can find from table, right? Before we learned how to find the table. And his is decrease. This is EI. The value is increased, I think. To H is decreased, right? From here to here is decreased. So to H is here is EI equals 0. So if you give you is H is shaft. If you 5 H 6 and 7, it means his fundamental is 0, right? His up is low, deviation is 0. So the H is 0. Just remember that H is 0. So H is basic whole because his 0 is basic whole. The fundamental deviation EI is 0. And JS is JS. The up and low deviation is symmetry. Symmetry with 0.9, right? His value is, so this is IT, right? It's IT divided 2 or IT minus 1 divided 2. IT minus 1 divided 2, it means this is spatial. We can explain later. So it means that JS, if give you this is JS 7, it means that his up and low deviation is symmetry with the 0 line. Okay, so from J to ZC, the fundamental deviation is upper deviation, is up deviation. So every deviation, the found deviation is close to the 0 line. The absolute value increased gradiently. The absolute is increased gradually. Okay. And for the shaft is different. So for the shaft, so this is a is A, B, C, D, E, to this A, this C. The A to the C, the A, the B, the C. Well, from I to hold hide them. Okay. Let's see. This one, yeah. This is here. Okay, from the ZA, ZB, and ZC. So he from BA to H, this is his up deviation and is low 0. So this is his low deviation is up, is larger. So the fundamental deviation of the shaft is nearly symmetric to the same letter corresponding or host respect with 0, 9. So they are the same letters, just use a smaller letter. So from A to H, the fundamental deviation is ES, right? This is ES, is up deviation. The absolute value decreased until QH equals 0. So the ES equals 0. So H is a basic shaft. The fundamental deviation is ES equals 0. And the same with the whole. The JS, the smaller JS, the up and the low deviation is symmetry with 0, 9. Its value is tolerance divided 2. So the up and the low are the same. So from J to ZC, the fundamental deviation is low deviation, EI. So the absolute value increased gradiently. But remember H, so from A to H, the fundamental deviation is up deviation from JC to from P Z to ZC. The fundamental deviation is low deviation, is EI. For the JS, his up and low deviation is symmetry with 0, 9. Okay. The tolerance of the whole and shaft present feet feather. So if the whole or the shaft fit together, we can choose different tolerance, right? So in the standard of ISO, using fundamental deviation to present the position and the tolerance to present the amount. So we learned this one. That means if I ask you to design a shaft and a hole, I give you its clearance is 0.6, and then if you are engineer or AI designer, you should know how to design his tolerance for the shaft and for the hole. Okay, so we can to learn how to design the tolerance. To symbol the tolerance though, the fundamental deviation plus tolerance grade such as F bar, F8, H7, H6, G6. So F is his symbol of the tolerance though. I mean, you know this one, right? F8. The H is the tolerance. ITH. He calls you know is this H is ITH. So the F is up. This is the whole, right?
Yeah.
So you know this this F, right? F is here. So his deviation, the fundamental deviation. So F, if you got this one, this ITH, right? This is F. F is here, right? His deviation, his fundamental deviation is here. His position is here, right? So if I give you F8, you should know ITH, the next you know, right? And this deviation, this value or this value, you should know from the table. And H7, H is his low deviation is
Zero line.
yes, it's 0 line. Good. This is 0. This is the basic hole. And shaft 6 is yeah, his up deviation is 0, right? So the H7 his low deviation is 0, right? He's in the basic hole or basic shaft. So G6 you should know his tolerance is 6IT6 and G is up, right? G is where? G is here, right? Is his up deviation you should know from the table. Break. Okay. Okay. I'm gonna hash the break.
Oh,
Okay, back to our class. And the tolerance, the symbols of fit. So when we know the tolerance of the hole and the shaft, the purpose of that we should to design the fit. How do they? Because they have the different tolerance. How can they fit and the fit type? The tolerance of the tolerance those of hole and shaft present feathers. So in the standard of ISO, the symbol the fit for the hole tolerance though at the numerator position. For the shaft tolerance though at the denominator position, like this one, the G7H6. So G is for the hole, right?
Oh, yes.
H6. So G is for the hole. So H, the small words is for later for the shaft. So just for easy printing, can write at this one. Okay, continue our class. Just careful, just listen carefully, okay?
Yes.
So like this one, this is the G. No, this is not the same. This not compare to this. This is not compared to this is for example. So this is the hole, the ES and the EI, this is shaft. So when you use this one, and you can know that is fit, this is clearance fit or interference fit or transition fit. So when I ask you to design a symbol part, and if they related the some parts related to the shaft and the hole, they have a symbol that you need to symbol you need to write or to draw the fit, because this is your work to design the fit. Okay. And any hole tolerance zone and any shaft tolerance zone can be fit together. It means that this one, sorry. This one, this is the hole, this one, and this one. This is the hole, right? That this is the tolerance figure is 28, page 28, right? We cover. So any hole tolerance zone and any shaft tolerance zone can fit together. This is the one. You mean that this one fit, and this one fit the smaller h. So that is for the transition, right? Transition fit. I mean this one fit a smaller h for the shaft. So but only the clearance or interference between the hole and the shaft influence the fit function. The fit function is mean that if they are the clearance, they can rotate very quickly. If they are interference, just to collection, tight is for the collection, right? So they can influence the fit function. So if you design the part or design the workpiece, how do you what the function do you design, and then you design the clearance fit or the interference fit, and then you design the tolerance, right? So for simple, the fixed one, the tolerance zone, and vary another tolerance zone to achieve different fit. This means that if you fix the one like the hole I choose the hole I choose H. H is mean that you fix it. You fix the one. The tolerance H is this one, right? This H. The EI 0 equals 0, right? This is the fundamental deviation is 0. So you fit this one, you fit this hole, and then you design a shaft. If your shaft is here, the tolerance is here, so this is clearance. If you design the shaft here, it's interference. In here, this is transition. In here is interference. So you fix one, and then you design another one. So the tolerance achieve different fit, right? Otherwise, if you fit the hole or the shaft is here, and you choose different hole like this one. So this is clearance. This one is interference, and this one is this one is transition. This one is interference. So you fix a shaft, and you choose different tolerance of the hole. They have the same fit, the same fit function. They're the same, right? So that is the basic system of the fit. The basic hole fit system. The basic hole fit system, it means that you fit the hole, and you vary the shaft. And the basic shaft fit system, you fit the shaft and you vary the hole. Basically, we just the basic hole fit is basically it means that the hole we choose the H, the grade, the H fundamental deviation. It means that the hole is the basic hole over here. Here the H, this is H is the EI equals 0. The basic hole, and we vary the shaft. And the basic shaft, it means that we fix the hole of the shaft. The ES is 0, and we vary the hole. So the position, the whole basic of the fit. So this condition, it means the whole basic fit. So the position of the whole tolerance, though it's fixed, the fundamental deviation is EI equals 0. Where the position of the shaft, the tolerance, the different fit can be obtained like this one. So we fit the hole. So this is 0, right? The low deviation is 0. So the upper deviation, it means the position of the part, like the IT1, IT2, ITZ, IT80. Okay? And vary the position of the shaft. If the shaft, we choose the A, we choose H, we choose Z. This is A to H is the clearance, right? And when we choose the J to N, it's transition. And we choose the T to ZC is interference. So this one is from the page 28, the figure, right? And also the shaft basic fit. The shaft basic of the fit. So the position of the shaft tolerance though is fixed. Its fundamental deviation is ES equals 0, like this one. So we fix the shaft. His ES equals 0, and his vary the position of the hole, like this one. So this is A to H, so it's clearance, right? From the J to N is transition, and from the P to ZC is interference. The whole basic fit and shaft basic fit is parallel. They are the same. So if you choose this one, and you you vary the shaft tolerance. The clearance is the same width when you choose the shaft. H is fix the shaft and vary the H, the hole. They are the same clearance or same interference or same yeah, the clearance and the interference are the same. Right? Change the fundamental deviation matrix of the hole and shaft. Standard tolerance grades invariant. The fit phase feature is the same. Call this two phase is the same length phase, such as the H8 F7. The hole we choose 8 IT8 is H, and the shaft the same tolerance, and F8 this is F7 this is F8 and H7 they are the same fits. The capital and low should be changed when write out the same length fit, the same. Yeah, because this is H, right? The H, the fundamental is like this is H, this is here, right? This EI is 0, is 7, right? H, the H is IT8, right? They have the same tolerance, IT8. And the here, and the F is where F is here, right? This is F. From the page 28, the F, the up H is here. So this IT7, right? So the length is the same, right? So that and this one is F. F is here, right? This is the same. F, sorry, for the whole, F is here. This is the shaft IT7. This is 0. So this one and this one is the same. And this is the same. This is right. This is the same. This is the same. And H, this is 7. This is 7. So its tolerance is the clearance. Clearance is TH plus TH. This is the total tolerance. The total tolerance is the same. So the fit is the same. I mean the same clearance and the same interference. This means when you choose this one, this tolerance or this tolerance, they are the same. For the parts, they are the same. Okay. Same means they have the same clearance. If you design a batch or lot of the parts, and the heat tolerance is H8, the shaft, the hole is H8, the shaft is H7, and you choose a shaft, you choose a hole, you choose a shaft that fit together. They have the same clearance or they have the same interference. When you design the tolerance or design the tolerance, they are the same.
These two have the same tolerance.
Yes. Yeah, the tolerance. So how to calculate the value is not important. We never do this. So you will never to design to calculate the value like this with 0, 0, 0, or 8 or 7 like this one. We cannot do that. We just to find from the table. That is standard because we do not revise the standard. So that is standards because we just apply it to design occupies procedure from the table. We just grasp to look up the value from standard table. The table, the number of values of fundamental deviation of shaft is table 2.5 lists the shaft fundamental deviation value. So, for example, look up the fundamental deviation value from table 20, page 32. Tolerance value from the table 2.4. Then calculate out the fifth F7, F6, and the 80 P7. So you calculate out the limit deviation. So if I give you, so because from the draw, they are just just alert like the fifth F7 or something. You must know his tolerance. What is his tolerance?
Minus 25. Minus 8.
Like the from this, the first one is this one, right? 0. So this is 5. So the F6 from the F6, F is shaft, right? Shaft is low, is here, right? Because this is F6, F6. This is F, right? From the page 28 from the figure, right? And the F6. So when you let me choose the figure. Page. We don't have the so much. Fifth, right, is from here, right? This is the fifth, right? His F, right? This shaft F is 25, right? So minus 25 is there, right? Right? So his IT, and then this word, this is E, sorry, ESEI, and IT6, right? IT6, this word. Back to 27, page 27, the table 2.4 for the value. 7, 6, 16, right? So this one is 16, right? So about this one. About this one, EI. This is is the tolerance is 60. This one is ER. This the balance
16 minus 40.
yeah. Get right because so when not so when the figure rotate the fifth F7 F6 and you should know his up deviation is this is UM. Up deviation is 25 UM minus 25 UM. The low deviation is minus 41. Okay. The next one. This one. Truth. This is also for the shot. This is P. Sorry. P. Right. T7. So this one. 80. Huh? Yeah, this is the T, right? This one. 7. This is 30. And then, yeah. This is 2. You know how to find the tolerance from the table. The basic fact is 5, 8, 9. 5, 8 from here, right? So this is the X. This is P, that's P. P from here, right? From here. Here is the 2. So this is fundamental derivation is the R. The derivation is the 2. And there is IT7. IT7. Here from the zero is 30, right? And the 30. And then you can calculate the up derivation is 62, right? So I think everyone can to know how to find the table. This is very basic skills for the engineers. Huh? And the here that is yes.
We didn't check that. Check. Yeah. Yeah. So this is basic skills how to find the table. I don't know how to tell about how to find the table. How to the student online to find the table. Student online. Hello. Hello, student online.
Yeah, and I think this is very basic skills how to find the table and to design the deviation. No one. But me. Okay. And pay a table 226 list the whole fundamental deviation value. I give you an example to find the whole, okay? Like the 5 H7 to find this one for the whole table 2.6. This is the 2034. 34, this is for the whole. The 32 is for the shafts. Okay, to find this one, and find the 80, okay, or HP 9, or 6, or the F 8. Okay, the whole. Find this is the whole. And find the
Yeah. Find the table. This one, how much is this one? This is H7. This one. Only?
No, it's not. They said they don't have microphone.
Huh? They can't hear me?
No, they can hear us. They said they don't have microphone.
Oh, they don't have the microphone. They can type online. They can type type. They can type in the line.
But you don't want to. We only have.
They don't have it.
Yeah, if they don't, if they have any questions, they have to send anything.
Seven? This is four. And no, this is the one, this one, this one.
Yeah, no, it's already 80. Actually, you already drew it. You drew the diagram already.
I know, no. I have not drawn down. This one.
Yeah.
And this one. H is this one, right?
Yeah.
It's H. This. Zero.
Uh, 25.
Yeah.
25. So now it's
You did 25, right?
yes. Yes. And this side is 25.
This one.
No. It's this side.
Yeah.
25. 25.
Hmm?
What's 6? The IT, what's 6? EI 30. ES 2 plus 16. Okay. Then you see 76 plus 3.
Okay. Everyone has some question? Do everyone can know how to find the standard, the fundamental deviation value? Do everyone knows how to find the standard values? Okay. I give you the PDF from the group.
We are using the before, but
Nothing. PDF.
Yeah, the book.
The first class I give you PDF. The book. Because there are some standard tables. Which one? PDF. The name is this. The name of this one. Okay. Second. You can change it. Okay, I can give to you later. Okay, continue class. Everyone understand how to find the table? Continue. Okay. And when we look at the page 34 and 32, when the shaft and the hole, I mean the fundamental values are the same, but the symbol are different. One is minus and the hole is plus. Could you find this procedure? Book, okay, 22, 24 page. Oh no, 20, sorry, 32, 34. And find the book. I mean the color fundamental deviation, like the balance, the A and B, A and the 34th A column. The one is the balance, right? For the whole, for the shaft, it's balance, right? For the whole is plus. The volume are the same when you compare it. Because for the whole is up, the low the shaft is low. Or compare the whole is up. The shaft is up, because when you find the page 28, you can find that. So they just have the same, but the thing just have the mirror, right?
Yeah.
28 mirror. Yeah, symmetry. No, mirror. Okay, so that's the symmetry. That the principle. Okay, and the pay attention to that following case, the deviation value should be added as an adjusted value. When you find the page 34, the the JKM for the K, when the IT, the tolerance is low, smaller and equal 8, and then the deviation, the up deviation should plus delta. You find that?
Yes. What's the economy?
JKM for the K when the tolerance smaller or equal 8, and the up deviation should plus delta.
Yeah.
Right? And for the when the M is the same, N is the same. When the for P to ZC, when the tolerance smaller or equal 7, the value for standard grades above IT7 increase data. Right?
Yes. But actually, in the K, I didn't see this information.
You can.
What we buy?
Okay, I'll give you an example, okay? And just know this thing. For the, you can understand, okay? So you know when the, for the KMN, when the tolerance, okay, this is very important, okay? Please listen carefully. From the KMN, when the tolerance grade is low, 9, and for the P to ZC, when the tolerance grade is low, 8. The deviation, the fundamental deviation should add delta.
Okay.
For example, let me see. The example is here. There's no example. Okay, give you an example. $5.80. T. Can you find the deviation? Yes. This is 6. Okay, so it's low than 7.
Capital P or small? Actually, is it big P or small P?
Huh?
This P, this is big or small?
Capital.
Okay. So actually, we add plus delta.
Ready your answer here?
We add plus delta.
Yes.
Okay. Now, yeah, IT is 19. ES is minus 26 plus delta. EI is minus minus 6 plus delta. Yeah. Minus 26. Yeah. 26. Yeah, check the one. 26. It's been 6. Of course, man. You went where? Look at T. Bro, look at where. It's here. Count. No. Yeah. Okay. No. Last. You must be asking. No. It's not like that's your answer. For me, it's 19 minus 20 minus
You have answer?
yes, actually 26.
Here, right? No, sorry. Now here. This is
19.
19, right?
Yeah.
So this one,
Minus 26.
26,
Yeah.
26 or 20, or 32.
26. 26.
Count the column, okay? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6.
Right, no one glass. Good. You be
1, 2, 3, 4, 5, 6. Actually, from this book, 8 right here.
That's it.
8.
32, my friend.
32.
Actually, the book is no. Actually,
Book is here.
yeah.
And
In this book, it's 26.
No, you went up.
No, Lava.
Bro, please. So this one. Go straight, my friend. 32.
No,
Minus
Lava.
32.
No, your book is wrong, bro.
Which book is wrong?
Your book is wrong. That's the minus 32.
Minus 32.
Yeah.
yeah,
Minus 32.
minus 32 and plus delta.
Plus delta. Yeah.
Delta from this 9, this is 87, right?
Yeah.
90, oh, 96 is 6. Continue to that line.
You have minus 30. Minus 30.
Minus 20.
30.
I mean,
Minus 33, I guess.
minus 23. This is
Minus 39. Yeah.
no, this is not.
Minus 33.
Yeah.
This one, this is minus 22 or 32
Yes.
plus delta, right?
Yes.
Because this class is low,
Mm.
low 6, 7, low equal 7, and then we should add delta. Delta is here, so this is what is the delta? We can find it from this column. This is 9 to 22. Continue to add 6 is 7, right?
Actually, that's
Right, 7. 32, 32.
It's 6, Laoshi.
It's 6. Oh, sorry, it's 6, right?
6.
yeah, 6.
So you add
Oh.
6.
So 20.
23.
Minus 26.
26. Sorry, 26, right?
Yeah, minus 26. Son, you choose the wrong one. Don't come to
Yes, but minus 26.
Laoshi. This is the right position.
Last week. So minus 26.
Uh,
Okay. Minus, is it minus or plus 19?
Minus.
Minus
Minus.
19.
Minus.
this is low, then minus 26.
Okay, that's it. Oh, that's it.
This is delta, is 26.
I know last week. See 19. Are we supposed to add it or subtract?
This one?
Uh,
This one?
yeah.
97. Add 6. Add 6 from now for
90. Yes. 45. How do you get it? It's 45. You add
add.
or subtract.
Add.
Plus, if you're adding 19, it won't be 45.
No, 90 less. You just know the half division. 90.
Oh.
The tolerance. Okay, the tolerance is also absolute, right?
Oh, it's absolute.
Yeah, it's absolute. So this one is the minus 45. Because this is the up deviation, this is the low deviation. The low deviation
Oh.
is smaller than the up deviation.
So when you
So
subtract this from this, you get
yeah. Right.
Okay. Sally, if
So-
you choose minus 26, the result would be the same. Really, wouldn't it be the same?
Continue, because there's so many content, okay? So much content. Continue, and then I just tell you how to find the table.
That's it. Can you give us another example?
Huh?
Another example so that we can get into another example.
Another example, okay? R.
You are arguing with someone don't wear glasses.
Another example is this one. This is a book. You. I'll give you that for you for this class. The table. This is for all. The top. Yeah. And
Have to find the delta. One.
Some tape on black. That's all black. And do the teacher. Yeah.
Come,
Okay.
lava. I can
I have to do
Really in your heart, sorry. No. 23, which I think the. How you put 23? No, she was in for 4.
How?
Yeah, more is R, right? It's captured. The capture R.
Capital R. It's low. It's down.
It's low.
It's down. So.
How you put 23?
I'm calm. Relax. Delta is 9. It's not 6. It's 9 because it's R7. Yeah. Because you asked me someone. Is it wrong or it's correct? You don't know.
R.
Yes, Lashi.
Now P.
R.
R. The 20. The 3 is B.
30 is P.
Is
Huh?
R. We have to find the book. 7.
Yes, okay.
Lashi.
Yeah, it's right. Okay, it's right.
Huh?
What about this? Yes.
Wait, relax. Oh,
Should be minus F. Logic.
hey.
Right? Yeah.
Lashi, it's not straight.
This line is not.
Yeah, it's fine.
Should be. It's not.
This one is
This
one. The inside. This divide 80. The round. What's your this makes sense. This nine for this.
It's what. Oh, yeah. Right.
It's what.
Not 32.
Yeah, we do that is very good. Yes.
So 32.
Yeah. And this is not. Since IT not at 7.
First 43.
At 7 is not this one. You have to change this one.
Is it
Word.
It's not 9.
You can take it.
Lashi, I take it.
You take it.
It's 9.
Here, right? 7.
Oh, see, Lashi, then you can't be using this book. It's hard.
It goes.
It's difficult much.
Yeah. Line here. Here.
So it's 11.
Left. Yeah, very good. They're right. Yeah. Right.
No, so minus 32. 43.
What's
What's 3 plus 11?
Delta.
Delta.
Plus 11 equals 3. What?
Is it 41 or 43? 43. Your book is not good.
I don't.
But before I went to them.
Because this one is
Yeah, from here. And here. Okay. From here. I'm sorry. Here, right? Here. See here. This line, this line, this dimension for this one, this is two, right? This for this one. This is the two color, right? Color, two line, and the one line.
oh, she's come. No, it's 70.
This line, so this line.
And 70 because about
Okay.
70.
We need to count. About this building is about the each number.
One here, and this one.
Lava, 5 classes.
Can you please clear this filter? So for this age, no next filter.
Yeah.
Change
Don't argue with each other.
Yeah, and
from here.
from here to and when the is low, then and then 7.
So if this
Up 7. If there is R8 9, then no data. So you have the data. When this is smaller or equal 7, instead that have a data, right? And use this word as a data from here.
Actually, what's the condition? When what is what? Before you add the condition.
Feature is if the current, the pressure current grade is up or is
So-
larger than 7 or 8.
So this,
Yeah,
if it's less than,
yeah, is less than 8 or 7.
Hmm.
And they have data.
okay.
Is larger than 7
Hmm.
or 8 and you know have data.
less than 7 for
Yeah.
P2,
Wait.
Feature is the most yeah, 8. Yeah.
Sandy, lower, we gotta add. But this is equal.
And then it have data.
Actually, lower than or equal
And
to.
then have data, so you have data. To the table.
Actually, that means even, we have to add.
Equal, equal, if
Yeah, example with equal.
you see,
This is.
when they, this is IT,
Mm.
this is target.
Basic.
Target grade
And then this
is
is position.
like the 7, this is 8.
Right.
And
And
then,
then
and
now we
then
need
if
to check
smaller, and
the
this is 7, then
Mhm.
value
IT.
for the other grade is above 97. When it's small or equal to 7, and then you have the data to the C. When after this C, the current grade is large 7. And you don't need to see the data. And for the JK, when the acceleration and the current grade is more than 8,
Yeah.
and then you add the data. When 7, 8, you don't need to have the data. Yes, yes. The data is here. You get the word from. So that from here. Yeah, the data. Yeah. So yeah, fine. So yeah, then is 11.
We add 11 to them.
Yeah.
Add 11.
Yes.
We have minus 43.
Yeah, that's 11.
That's 11. You get what?
Minus 32.
And then we add both of this one.
Okay, continue.
Yes, yes.
So why add the adjusted value data? Because understand? So why add the adjusted value data? Because for the whole, when the pressure is higher, is very higher, so it's very hard to manufacture it. And later I will explain it again. Why add the data? Okay. The fit characteristics should be same for same name fit. I have already explained that before. In other words, the limit clearance or interference should be equal. So it means that when you fix the hole or fix the shaft, value the hole, value the shaft, they are the same. So the manufacturing difficulty should be same to the hole and the shaft fit together. That means that if the fit, okay, this is the fit. This is for the alone, the hole alone, for the shaft alone, for the fit. So if you design the hole is 7, and then you design shaft is 1, is 2, is F2. No, this is not competitive because 2 is very hard to manufacture, and 7 is easier to manufacture. And then you fit, you design this. This is no meaningful. Yeah, it's useless, not meaningful because this is a tolerance. The tolerance clearance, the tolerance is very large. The tolerance is large, and then it's very pressure is small. Yeah, it's no meaningful. So I mean this are almost the same. So the manufacturing difficulty should be same to the hole and shaft. Like the same occurs, like this one is HP, H8, P8, M line, H line, they are the meaningful, right? So in other words, when the basic size is not 500 to machining high pressure hole is difficult. So for high pressure fits, the hole tolerance grade is not 1 grade then to the shaft tolerance. This means when you're machining high pressure, you manufacture a hole is difficult than to manufacture a shaft. Because this is a shaft, you just use the laser or use the tone and turn a hole. And then you make a shaft. You use different drill to drill a shaft, drill a hole is difficult to it is more difficult, it's much difficult than to make a shaft. So
Is there a practical part of this lesson?
Huh?
Is there a practical part of this lesson?
particle,
Yeah.
Right.
Lab work. Something example. Lab.
you mean the experimental?
Yes.
This class no.
Oh, wow.
I mean the manufacturing, fundamental manufacturing course. I mean next semester
Oh.
you can learn that course. You can
This one example. You bring this book or you give us the thing.
give your example.
In exam. You give us the table or we bring the book.
You mean this one?
No, this table.
The table and
Exam.
a more exam.
In the exam, final exam,
Find the exam.
you give us the table or we bring the book.
You mean that the result, follow result,
If you allow us. to
you mean
bring
the follow result, follow test, follow test. I give you the table, yeah. Got it. You mean that you bring the book. I don't know if allowed to bring the book. I mean, to follow the exam, I will give you the table. Maybe I ask. Give you the table, yeah.
If you become engineer, you feel you will carry.
Please, yeah.
Okay, continue. When I
Start with it.
We just added one.
break time. Okay.
Each class, 40 minutes. So. I'll check.
Break time.
Okay, break time.
Okay. Lava. Lava. No, you can buy glasses if you can't see.
Okay, where? Here. For the calmer in machining high pressure hole is difficult. So for high pressure phase, the hole tolerance grade is not one grade than to the shaft tolerance, like H7, F6, G7, H6. So for our mechanical engineering, if the tolerance grade is large, it is smaller than 7, so it belongs to the higher pressure, pressure. So one for the high pressure, the whole grade tolerance, the whole tolerance grade is low, one grade than the shaft, like the is low means that tolerance, the value is large, right? So the H7 is F6, G7 is the hole is IT7. The shaft is IT7, the hole is IT7, the shaft is IT6. So the shaft is with a high pressure, the hole with a little low pressure, low pressure. So for common pressure, the pressure of hole and shaft fitted together is the same, like the low pressure, the H8 or P8, they are the same tolerance grade, right? So for example, how do you hide this one? For example, the H the phi, the capital phi, the phi 16, the basic size is 16, H7 F for the hole, F6 for the shaft. So this is the whole basic, right? Because this H is a basic fit, the whole basic fit, the basic. So from the table 2.4, are you interested to find the table the values? Try again. Find that.
Yeah. Oh, 16, H7. F6.
This is the 18 for the H7. The tolerance this is 0 and the tolerance is 18, right? It's 16, the basic size. Right? IT7. Table.
18.
Yeah, 18, right?
Yeah, 18.
And then for the shaft, F6. Very quickly, find the table.
Heavy mouth.
11,
16.
16.
16 minus 16. Plus 12.
So this IT7. IT7. IT6. 11, right? Yeah. This is the tolerance 11, right?
Huh? Actually, F6.
So the maximum, yeah, 60. Yeah,
16 is maybe 16.
11 is the tolerance.
Oh,
Yeah,
actually, it's good. Actually, how is 11?
tolerance is 11. IT6
I'm 6.
is the page 20, 27.
27.
It's 6, 11, IT6, right?
Yes. 11.
Right? This is 11, right? So they are the clearance feet, right?
clearance fit, the maximum clearance is 45, the minimum is 15, right? So the minimum is from here to here, the maximum is from here to here, right?
Actually, you need to subtract 46 minus
What?
18 minus 27.
What is balance? Is this one?
16 minus 11.
You mean this one?
I mean, how do you get the 45?
45? This one?
Yes.
This one. The ES minus EI. EI, 27 EI. So this is the maximum clearance, the maximum clearance, right? So the minimum is here to here.
Yeah.
0 minus 30. So this is it, right?
Yeah.
So for this one, so if I design the whole is F7, is the colors grade is 7, and we use the fundamental deviation, the F. So for the whole, for the H6, so we can to see the clearance or the what is the clearance? What's the value that clearance is? So and also this is shaft, right? Shaft is H6, so 0. This ES is 0, right? The basic, the whole the shaft base. So this H6 is also 11, right? Because the IT is at 6. You have already find that, right? It's 11, right? So it's 11. And then for the F7, so this one, IT, this F is, this is minus, this is plus, because the table, because 20, the 32 and the 32, 34, they just have the same value and the different symbol is, for the whole is plus, right? For the whole is plus, the whole, yeah, whole is plus and the shaft is minus, right?
Yeah.
So the IT at 7 is 18, right? So you can get this, get this ES deviation is 34, right? So you can to calculate the maximum interference and the minimum interference. They are the same. That means that when you design the H7 for the whole, F6 for the shaft, or you design the F7 for the whole and the H6 for the shaft, they are the same. The fit function is the same. That is EI equals minus ES. And for the H8 and P8. So this is low, this is higher pressure. So this is a little low pressure because the tolerance grade is 8, right? They have the same basic size. The tolerance is 8. And this is capital A, capital H. So this is whole basic. So this is 8. This is 0. When you find the table, you can get the up deviation is 27. When change the table, right? 87, 6. And then P8 is 8. 8 is not lower than 7. So we don't use to add the data. It's P8. The P8, so when the low deviation is plus 17, plus 18, the up lowers, the up deviation is 45.
What are we supposed to be thinking about deltas?
Delta what?
P small.
Huh?
is
P8. This is shaft.
sharp, sorry.
Yeah, P shaft.
There's no need to do
Yeah. Shaft is not lead to add data. Yes. Yeah. Hold on, then we need to add a data. Sorry. Yeah. And this is when you calculate the maximum is plus. This plus is interference, and this is this is clearance. This is interference, right? So this is transition, right? Transition phase. And for the shaft, they are the same. This is ATP. This 16P8, and for the hole and the shaft is 8. So for the shaft, so this ES is 0, right? So IT8, the greater 8, the greater 8 is this one, right? Is 18. Oh, sorry, is 27, right? The tolerance. So it's a minus 27, right? So the P8, this is the shaft.
Yes.
So sorry, this is for the hole. This is the shaft. This is the hole, right? This is for the hole. This is the captain. So this is minus 80. So it's the same. And this is minus 45, right? So when you design like a hole, like a shaft, they'll fit. And when you design this one is a shaft, is a hole, they are fit. They have the same maximum interference and the same interference, the maximum interference, right? So they are same fit. So ES equals EI, minus EI. And for this is the P6. It means that the tolerance grade is no 7. Yeah, it's no 7. Is that the pressure is higher. So this is H. This is for the hole. So is 0. So this up deviation is plus. It's over. It's plus 18, right? The IT7. You can find the table IT7, right? And then for the shaft, the low deviation is plus 80. So this is 29. So the maximum, the interference, like here to here, so is minus 29. The minimum is 0. So this is interference, right? So for the shaft basic, like the hole is is 0 and 11 here, right? And for the where? For the shaft, that means here. No, here, that one. For the if with this one and we check from the table from the P7, you can check it. P7. If you don't add the data and the up deviation is minus 18. 18 plus 8 data, right?
Yeah, because
Yeah, when you don't to add a data, so it's a minus 20, a minus 18, and then the deviation is 36, right? So if when you use this one, the minimal, the maximum, yeah, where is it? This one. When you don't to add the data, so you use this one, right? So can you calculate this one and this one his maximum interference and minimal interference?
By adding the delta.
Huh?
By adding the delta.
No, not add the data. I mean this one and this one, this tolerance. The blue tolerance, and to calculate his maximum interference and minimal interference.
Maximum is 36, minimum is 29.
Maximum is 36,
minimum is
yeah.
29.
Minimal
29.
29, minimum.
Yes. Which one? Minimum 29.
The blue one, blue tolerance.
Yeah.
The maximum is 36, right? The minimum 29, minimal interference.
Oh, minimum interference. Oh, sorry. 7.
Yeah.
7. Minus 7.
Balance interference is 7, right?
Yeah, 7.
So that's because they have the same feature, right? But the interference is different with this one.
Yeah.
So when the for the whole the pressure is lower than 8, lower than 8,
Yeah.
lower than 7, 8, lower than 7. We should add a data. So when we add a data and then you find the table data's value and then this tolerance is moved up to here. So is minus 29. This is minus 11, and then with this tolerance and this tolerance, can you calculate his maximal interference and minimal interference?
Maximum is minus 29.
Yeah.
Minimum is 0.
Yeah, it's 0, right? So when you add a data and they have the same fit clearance, same fit, right? That is why when the values is lower than 7, you should add a data in order to make sure when they have the same fit, they have the same the number have the same number, the same fit length have the same fit. Okay. Look up the fundamental deviation value from table and then calculate out the other limit deviation. I think you know how to find that, right?
Yes.
You already know how to find that. Okay, and another thing you should pay attention to when the tolerance is from 87 to 11. And then the tolerance value is odd. It should be rounded the even number immediately below, like the JS. So you can try to find the JS, find the table, JS 8. JS is for the shaft. It's smaller.
That is ITN over 2.
Ask for my ITN. J squared.
JS8. Now she said JS8. It's 99 by 2. How you done? 19.5.
9.5,
Around 19.
90.
Yes.
Already check the number 90.
Yes.
IT
To be 39 divided by 2.
50, IT
ITP.
8.
Yes.
Yes, you'll be 39 divided by 19.5. You round it to the low. You will be 9. It should be 19.4.
The oddness is about the 7. So 19.5.
You round it down. And giving number you round it up. That's you round it down. Because 19 is odd. If you round it, you don't have anything.
Okay, you can find it's 20, it's 90 line, 30 line, right? There's a round it, so it's divided 2. And then you use 90 Actually, the JS, we don't use it very commonly. We just when we design the bear, we just use the JS tolerance. But for the bear, it's standard. Okay, exercise 6, exercise 3. This is to follow the fit, give out the limit deviation value, the tolerance, the limits of size, the limit clearance, interference during the tolerance zone. What class fit it is? So like this 8. So the diagram is 8 M8, and the shaft is 7. So when you draw the figure, you just to notate this 8 M8 and H7. You should know what is it. Why?
As we try.
Yeah, try. But just try to find the figure. Tolerance figure. This one.
Minus when you subtract single, you get 5. No. But the code is 8. No, we don't add the. Yes, they can equal 8. You don't can. At least yes. I should be here. Cheers. Translation. Yeah, because how much is it? 0 minus 2. And 5 yes. H is not shot. H is down. Transition. What? When you have this.
Yeah, this is you when the part already eight, 7, 14, zero nine. Yeah. It's not very expensive. Which page? Zero nine. Which page? Which page? Okay, you have already finished that. Okay, so you the first you just to find the IT7 is the tolerance grade is 30 8 IG8 is 46 from table 2.4, right? Find that one. And fundamental deviation is ES is minus 11 at the data because this is M8. So you should to add the data. Data is find the table. You can find it is 16. And then it's minus it's plus 5 from table 2.6. And shaft is fundamental is 0 because this is basic shaft. And then you calculate the ES minus IT8. When you figure the tolerance zone, it's very easier, right? Then you can to calculate this one. This is the shaft. This is the hole. This is for the shaft. And then when you figure the hole, the tolerance zone, and then you calculate the Dmax for the hole and the Dmax for the shaft. It's very easier, right? So this is the transition fit. So this means that when I give you this one, and you should know his tolerance zone and his pressure value. Okay, this class content. So the exercise, if it's about 12. So this is for the homework, okay? Yeah, but if we have time, we can do it in the class, but we don't have time. This table, the homework is page. Okay, page 53.
Yeah, 53.
50, page 53 is 2, 5, and then to drive the tolerance zone. To drive the tolerance zone diagram. Okay, draw the diagram. Okay, send your PPT to the group. Please finish the homework. Okay.
Online student, please finish the.
For media, how to check the table.
Mark it.
It's a fun.
Mark manual. Yeah, mark manual. I came early. I give you. Actually, let me send them.
Okay. This one, this one. The table.
It's in the page. I can't see it.
Peace.
Please,
Finish the homework.
Please draw the
There's some tolerance.
tolerance zone diagram.
Yes.
Tolerance.
Tolerance.
L-E-R-A-N-C-E zone.
Diagram. Diagram. Right?
No.
One and
One
one
M.
Oh, I forget she mentioned.
Diagram. Okay.
Class is over. Class is over. PPT now.